Today we'll talk about current, electricity and heat, and the question we have here reads: an electric heater is made of a wire of resistance 100 ohms and is connected to a 240 volts main supply. Determine, for Roman 1, the power rating of the heater, Roman 2, the current flowing in the circuit, Roman 3, the time taken for the heater to raise the temperature of 2 kilograms of water from 23 degrees Celsius to 95 degrees Celsius, and the specific heat capacity of water is given as 4,200 joules per kilogram per Kelvin. And finally, the cost of using the heater for 2 hours a day for 30 days, and the power and lighting company charges 18 Kenyan shillings per kilowatt hour. So, for Roman 1, we are required to calculate the power rating of the heater, and we know that power is given by the voltage supplied times the current, but in the question we are given that the voltage supplied is 240 volts, so we have 240 volts, but we do not know the current. So the first thing we need to determine is the current, and for us to know the current we are going to use Ohm's law. Now from Ohm's law we know that current is equal to voltage over resistance. Basically we know that resistance is equal to voltage over current, that is from Ohm's law. So applying this, we make I for current, make I the subject, so I is equal to V over R, and that simply means the voltage here we are given as 240 and the resistance we are given as 100 ohms. So the current is 2.4 amperes. From there we can now get the power, and the power is equal to the voltage, and the voltage is equal to 240 times the current, and the current is 2.4. Finally, this worked out should give us 576 watts. Next, we are required to calculate the current flowing in the circuit, so that basically is 2.4 amps from what we worked out. So current we know is voltage over resistance, which we have as 240 over 100 ohms, and that is 2.4 amperes. So very fast to Roman 3, the time taken for the heater to raise the temperature of 2 kilograms of water from 23 to 95 degrees Celsius. By the principle of conservation of energy, we know that the heat lost should be equivalent to the heat gained. So the heater is losing heat to the water, and water therefore has its temperature rising from 23 degrees Celsius to 95. So for the heater, the heat loss is given by power times time, and for water the heat gained is given by mass times specific heat capacity times temperature change. So delta theta represents temperature change, C represents specific heat capacity, and M for the mass of water. So the power already we have worked out earlier on, so we have 576. So we have 576 times time, so let's represent it by letter T, and that should be equivalent to the mass of water in kilograms. We have 2 times specific heat capacity, we are given as 4,200, and we have to multiply that by the temperature change, and the temperature change is from 23 degrees Celsius to 95, so we subtract 95 minus 23, and this therefore should be 576 T on the left hand side, and on the right hand side when we work out this we should get 604,800 joules. So that means that the time taken is, dividing both sides by 576, we get 1050 seconds. So we can also get this in minutes, and that means we divide 1050 by 60, and that should give us 17.5 minutes. So finally, for the last part, the cost of using the heater for 2 hours a day for 30 days. So first of all, we need to determine the number of units. So number of units, so here we have 576 watts, so that is equivalent to 0.576 kilowatts. So we have 576 divided by 1000 to have it as a kilowatt, and we have to multiply that by the total hours. So we have 2 hours a day and there are 30 days in total. So this worked out should give us 34.56 kilowatt hour. So these are the units we have, but we know that from the question 1 kilowatt hour is charged at 18 Kenyan shillings. Therefore, what will we have for 34.56 kilowatt hours, rather kilowatt hour? So cross multiplying, this implies that the cost of using the heater for 2 hours a day, 30 days, should be equivalent to, so 34.56 times 18 divided by 1, and that should be 622.08 Kenyan shillings. So we have 622 Kenyan shillings and 8 cents. So that is it for this question. I want to thank you for your patience. Thank you for watching. See you in the next video.